Welcome back to Advanced Skills Learning. Gen AI prototypes are easy. Production systems are hard. In this series, we focus on the decisions that determine whether your system actually works at scale. Here's a mistake that almost every RAG system makes. They assume more context leads to better answers. So they increase top K, expand the context window, and push more data into the prompt. And surprisingly, the answers often get worse, not better. This becomes especially critical as your system scales to more documents and more diverse queries. The problem is not lack of information. The problem is too much low-quality information. When retrieval pulls in irrelevant or weakly related chunks, it introduces noise. And that noise competes with the actual signal the model needs to answer correctly. In real systems, even a small percentage of irrelevant chunks can significantly impact the final answer quality. This leads to a hidden failure mode. The model's attention gets diluted across too many tokens. Important facts are still present, but they are harder to focus on. And the system fails silently, producing answers that sound correct but miss key details because the model doesn't ignore bad context. It tries to use everything, which increases confusion. A common reaction is to scale everything. Increase top K, use a larger model, expand the context window. But this is like pouring more water into a leaking bucket. You are increasing volume without improving quality. This approach increases cost and latency without actually improving the signal quality of your input. This is where context compression comes in. Compression is not about shrinking text blindly. It is about removing irrelevant content and preserving high signal information. The goal is to give the model less, but better input. Think of compression as improving signal-to-noise ratio rather than just reducing size. There are three main approaches to compression. Extractive compression selects the most important sentences directly from the text. Abstractive compression rewrites the content into a shorter summary. And hybrid approaches combine both for better control and accuracy. Choosing the right method depends on your use case, especially accuracy versus efficiency trade-offs. Extractive compression is simple and reliable. It works by identifying the most relevant sentences or passages. Because it uses original text, it reduces the risk of hallucination. This makes extractive methods easier to debug and safer for critical applications, and that is what makes it a strong choice for factual or compliance-heavy use cases. Abstractive compression takes a different approach. It generates a summary that captures the meaning of the content. This can significantly reduce token usage. But it comes with a trade-off, because details can be lost or slightly altered. As the model rewrites content, it may unintentionally omit edge case details. That's why many production systems use hybrid compression. They first extract the most relevant parts of the document. Then they summarize those parts into a compact representation. This balances accuracy, efficiency, and context size. This layered approach is why hybrid compression is widely used in enterprise RAG systems. Now here's a quick check. Which approach reduces tokens the most? A. Extractive. B. Abstractive. C. Hybrid. Keep your guess. The answer is B. Abstractive compression reduces tokens the most because it rewrites content into shorter form. So, where does compression actually happen? Compression sits between retrieval and generation. You retrieve candidate chunks first. Then you compress them into a high signal context. And only then do you construct the final prompt. This step is critical. Without compression, your prompt becomes bloated and noisy. With compression, your prompt becomes focused and efficient. And that directly improves both accuracy and latency. In a real system, the full flow looks like this. A user query triggers retrieval. Retrieval brings back multiple candidate chunks. Compression filters and condenses those chunks. And the LLM generates an answer using this optimized context. Placing compression at this stage ensures only optimized context reaches the model. Each step in this pipeline directly influences the final answer quality. Here's another quick check. What happens if you skip compression? A. Faster responses. B. Better accuracy. C. More noise. Keep your guess. The answer is C. More noise. And that noise reduces the model's ability to focus on what actually matters. It not only affects accuracy but also increases hallucination risk. So here are the key takeaways. More context does not mean better performance. Quality of context matters more than quantity. And context compression is one of the simplest ways to improve RAG systems without changing models. In production systems, this is not optional. It is a core optimization layer. Because the difference between a good answer and a bad one is often not the model. It is the quality of the context you feed into it. Thanks for watching. If this video helped, Like the video and subscribe to Advanced Skills Learning for more Gen AI explainers, practical architectures and quick quizzes to test your understanding.